Just wanted to give you a brief rundown on how to use IACTeasyEda. In a case of trying to find devices, for example, if you wanted to find the NE555 timer, one thing you might like to try and do is use the library search over in here, and then type in something like NE555, and then hit search. And now you can see all the different stuff that's available. And if you just restrict yourself to the LCSC, that's fine, and that'll work reasonably well. But if what you really want to do is a thorough search based on price, then my suggestion is you go to the LSC parts. But if you're just looking for a dip, here's a dip 8. It shows you the outline. It shows you that it's in stock, and it shows you how much it is. But look, that's 13 cents. Now go to the next one. And now that's 12 cents. Now let's do this one here. And that's 7 cents. So that's kind of a big deal. It's a change in price somewhat. And it's still a dip. And that seems okay, I guess. If you went to one of these SO8s, prices don't necessarily go down. So if what you're looking for is an inexpensive way to build, your best way to sort things by what's in stock and by price is to go and do the LSC parts search. So that'll take you over to the part search area, and you can type in NE555 and then do a quick search, and that'll give you everything that is close to what you're looking for. And now you can take a look for oscillators, and then you can sort for things that are in the DIP 8 package and that are in stock. And then you apply those changes, and now you can sort by price. And herein is the part that you want, manufacturer part number, and you can scroll over and find the LSC part number. That's key. Copy that, because if you get the LSC part number, then when you go in here and you paste in the LSC part number, you can do a search, and you'll find right away the part with its outline and the part number. And that's 7 cents each. So that's pretty cheap, and it's a through hole, so you can solder it directly into the board, or get sockets if you like sockets. So that's a way to go. And now hit escape to get out. Once it's placed into your area, you can click on it, and you can see the supplier of the footprint is LSC. That's the contributor. That's pretty reliable. I like using LSC, and I did that for all of these parts. So then when you want to get your parts, you go to the build of material, you do the export, and what you want is the designator, the supplier, part number, quantity, footprint, and price. Hit export, click OK, hit cancel, and now click on order check parts stock. Since these are all LCSC parts, what you can do is you can scroll over to the part number for LCSC. Since you've got an LCSC part number, the price I don't see is here. Quantity is not here, but there should be a place in here for, let's see, this would be the manufacturer. This is the manufacturer part number. Here's your quantity. So now we've identified the semantic information. Footprint I don't think is here. This is a designator, so that would be the customer part number. and you'll want that because it'll come on the package, and you'll know that this is C1 and that is C2. And then this is going to be a description, and that should be sufficient. Footprints aren't given. The supplier, yeah, we don't need that. Value, the value is here. This is the value. And let's see, what else do we need? This says footprint. I think we can use description for that. That might be all right. And now everything has been assigned except for the price. Let's see. Hit next. And now you can see the total is 26 cents. And everything is in stock. And now if what you want to do is instead of getting 1, get 10. Now it's $2.60. You can add it to your cart. I have other things in the cart, so that's added up. And then you can go back. Got everything in the cart that you need to build the board, but you don't have a printed circuit board yet. So what you want to do is you want to convert this to a PCB, which I have done already. And then you want to do the auto route. Now auto route can be done either locally, if you install the auto router, or in the cloud. To install the auto router, I downloaded the auto router and then I ran it on my Mac. I went sh Mac 64sh. There's also a version available for Windows and for Linux. Once you start routing locally, things run really fast. If you try and route using the cloud, it takes forever. So route locally if you can. Here I'll do the run so you can see how fast. And that was very fast. And now you can see the routing that it did. Not terrible. I could probably reroute this if I wanted to. The top layer is in red. The bottom layer is in blue. Silk screen is in yellow. And now I think maybe you've got your printed circuit board layout, and what I'd like to do is take advantage of the SMT service that JLPCB performs, but that means using their parts, and so it also means using SMD parts. So basically you have to replace every single part that's through hole with an SMD part. So for example, this LED here is a red LED. You have to get a surface mount device to replace it. Something that is surface mount. Perhaps in this library here, if we type in LED, here's an LED in 0603, and it looks like you can get it 0805. That's a good size. So let's get that, and we'll have to reflect it around, but what we'll do is we'll place it, hit escape, and then what we'll do is we'll delete this, flip it around by doing a flip horizontal. Then let's drag it over. See if we can get things to bond. It looks like we did. And now we should be able to look at the attributes. So that looks all right. Let's take a look at the, let's save first. So we've made a copy in case you haven't, in case you were wondering. This is the timer, same timer, but now it's called SMT. Didn't want to mess around with the old one. And so now we've got two schematics. There's this one with through hole, and there's this one with surface mount. And if we go to fabrication and look at the bomb, let's see. It looks like it's all LSC parts assigned. We can export the bomb. We're going to have JLC PCB do the export. Let's check for stock. And what do we got? It's this LED. And it looks like everything has an LCSC part number. Which means everything is in stock. And we can now get a price. And it's $2.31. But we have minimum orders here of 50 and 100. So things got a little more expensive, but only because we're making so much. And it all looks like it's in stock, so that's cool. So now if we go to our fabrication facility with SMT components, we can do a PCB order. And now we can add our Gerber file. So we'll go back to IACTeasyEda and we'll PCB order. Oh, we haven't converted this to a PCB yet. This is going to be a completely different PCB. Let's do that. Convert to schematic to PCB. This should be a rather different PCB. And certainly it is, because we can see now everything has been turned into a rather smaller circuit. We'll put the resistors all in one place for no particular reason. Let's just line everything up. Put our LED in here. Well, that should probably be flipped around, right? And now I think maybe we're ready to do our routing. That was fast. And let's zoom in on this a little bit. It's pretty neat. Very compact. So we can save that. And now I think we can do a PCB order direct. And what we'll do is we'll export the Gerber file, order the PCB with surface mount at JLC PCB. PCB price will be $4. We'll get our coupon. It looks like we can have $10 off. Order the PCB. And what do we get? The Gerber files get automatically uploaded. We should see a rendering. And there it is, all on one side. That's pretty cool, actually. So $4 includes the assembly costs, and you get free parts for the initial assembly. That's the intro price. Pretty cool, right? Let's take a look at this thing now that we've got things rendered. And here's what it looks like with the LED and all of the chips nicely laid out. That looks very professional and very fast to fabricate. So, thought you might like my little demo there. We just went from, it's actually kind of cool. We went from a through-hole design, which you can hand solder, to a freely created surface mount technology design. And you can sort of see how you can go back and forth, and it's really cool to see the contrast and difference in size and the microelectronic packaging capabilities here. Really something. So, thought you might like my little demo. Thanks a bunch. Talk to you later. Boy.